For this problem, we are looking at accidents at rock concerts. So let's go ahead and look at this quantitative response right here. We have a histogram on the left and a box plot on the right. It's important to note they are showing us the exact same data. I don't know if I'd call this essentially symmetric, but we're going to have to. So it is definitely skewed to the right. I see the right skew, and I think what they're doing here is they're omitting the outliers as part of the skew, which some people do that in their interpretation, and they have decided to. So removing these outliers, you might say it's got a little bit of a skew. So it is skewed to the right, and with two high outliers at 36 and 48, and let's see that again. There's our 36 and 48. And then most victims are between, and I believe it was 16 to 24. And if you look right here, this is the IQR. Since it has a right skew, we are going to use the, and outliers, I should say. Since it has a skew and outliers, we should talk about the IQR. And that's pretty easy to see in here. This is probably, that's a little higher than 16 maybe, but it's much better to say 16 to 24 than the other option of 24 to 30, because there's really not most people in here. If you see, there's only 25% of data above this line, where there's a lot of data in here. And you can see the same thing, that's a lot of data over here. So this looks to be our right answer right here. Remember, you're using the IQR and the median to talk about it because the data is skewed. What features of the distribution can be seen in the histogram that cannot be seen in the box plot? Well, histogram really tells you the shape. You won't be able to see the shape that well in the box plot. So we can see the outliers in both, so that's not really a concern to us. The outliers are available. We'll see it right here. There's the outliers in the histogram. There's the outliers in the box plot. Oops, we can probably put this up so we can see both at the same time. The IQR can be seen in the histogram, but cannot be seen in the box plot. You can't see the IQR in the histogram. The IQR is this. It's the box of the box plot, and there's the median. The slight increase between ages 20 to 22 to 24. Wait, the slight bimodality. That is definitely it. And you can't see the median in the histogram. You'd see that in the box plot. And there's the median. So this is part of shape, the little bit of bimodality, and that is easily seen in the histogram. So histograms really show you shape. Box plots are not a good indication of shape. Let's look at the last one. What summary statistics should we use and why? Definitely the median. The median would be most appropriate because it is slightly skewed and has outliers. Important to know that median goes with skew and outliers, where mean goes for symmetric distributions. What summary statistics should we choose and why? And since we chose the median, we must choose the IQR. Now remember, the median is the 50th percentile, and the IQR is the distance between the 25th and the 75th. They're all based on percentiles. So since it is skewed, we are going to use, and since it has outliers, we are going to use the IQR as a measure of spread. This is a measure of spread, IQR. This is a measure of center, median. And the two other choices there, the mean and standard deviation, would be for normally distributed data. Let's look at some cereal boxes here. I believe that's what we're looking at. What is the range of these sugar contents? And you can't tell this from the histogram. The answer is not going to be 0 to 70 because these are bins that collect the data. So 2, which is the minimum, would go into this bin here. 2 is one of the counts of the cereals. And you do have side-by-side box plots here, and these are both being displayed in one histogram. So 2 to 63 is the range. So the range is 63. And I think I might have said 2 to 63, but it's 2 to 65. 65 minus 2 is 63. And you can only see that in the box plots. Describe the shape of the distribution. Definitely bimodal because we have two central points to the data. We have the adult and probably the children's cereal. So this is definitely bimodal. And once again, this is seen in the histogram. What aspect of breakfast cereals might account for this shape? So most cereals have similar sugar content. Not really true because we have adult cereal and children's cereal, and it's not like most have similar sugar content. There's two different types of brands. Sugar content varies greatly among different cereals. Now, a lot of people get tricked into answering that one, but think, what if we had like your average cereal in the center, like a bunch of average cereals, and there was like the super sugary ones, and then the really like not sugary ones, super healthy ones? We could have a unimodal distribution because you'd have a whole bunch in the center and then super sugar and then really healthy. And there'd be a lot of variation. So although they do vary a lot, that doesn't account for the shape. What counts for the shape is cereals tend to be either very healthy or very sugary. And that gives us the two peaks because look at it. They're either very healthy or they're very sugary. And that's why we get the two peaks, the two central mounds of data. So right here is our answer. Last part, or one more part for this. Are all children's cereal higher in sugar than adults? And here's the lowest child, which is higher than the highest adult. And the answer is yes, because that is the min of the child distribution, and that is the max of the adult distribution. Continue on to the last part. Which group of cereals varies more in sugar content? Okay. So looking at the adults over here, you can see the IQR is bigger for the adults, and the ranges are about the same. So look at the answers. Although the ranges appear to be comparable for both groups, the IQR is larger for the adults. We need to go over to this one right here. So they both have about the same range because when we talk about variation, that would be spread. So the variation in adults is same for the range of children, but the IQR is a little bit bigger, and IQR is a measure of spread, and spread is variation. There we go. Last problem, side-by-side stem and leaf plots. And this problem is the bane of people's existence. There's always one per homework assignment. But we're looking at percent here. Always good to look at the key to start. 6/0 means 60%. So the maximum in region 2 is 60, and the maximum in region 1 was 12. So let's go ahead and look at our box plots. So here's the box plots. And by process of elimination, we can figure out which of these is the proper box plot. Now let's look at one that just is graphically incorrect. If you look at this right here, this is the IQR. Going from Q3, you would have to go up 1.5 IQRs to get to an outlier. And I want you to think about this. Look at where I'm putting about in the middle here. This line goes up about 2 IQRs. When I say IQRs, that is the length of the box. This is the middle 50% of data. And then I'm taking this, if you saw me do this in class, and then I'm going up 1 IQR. You see I just went up the height of that box again. And then I'm going up 2 IQRs. As in, this point up here should be an outlier. This is graphically incorrect because outliers start 1.5 IQRs. And so we should have seen an outlier up here. The whisker of the box plot cannot go up this far. So graphically, that is very inaccurate. This is a wrong one right here. What else do we have? Well, I want us to take a look at this one right here. This box, again, is the IQR, the middle 50% of data. And if we trace this over to the left here, we can see this is almost at 50. Let's call it 48. 48 for region 2. And let's go over here. And now at 48, there should be 25% of data above it. And there's like at least 15 observations. I haven't counted them, but there's a good many observations inside of this stem and leaf plot. And if there were to be 16 observations, you break that into quarters, there should be 4 observations in the upper quartile, the top quartile, the fourth quartile. And once again, above this right here is 25% of the data. This is about at 48. And if you take a look at 48, there's no 48 in the data set, but where 48 would be, there's not 25% of the data above this. So this has to be inaccurate because we don't see 25% of the data above this line. And so this box plot does not work. Now, last but not least, I start looking at region 1. I'm going to not pick this one yet. Let's look over here at this. And if you trace this over right here, you can see this has to be above 15. I think everyone agrees that that's maybe 17, 18, and that's the max of region 1. The maximum value of region 1 in this box plot is 17, 18. Now look over here, the maximum for region 1 is only 12, and that's why I skipped over this one, because the max for this looks to be about 12. That's reasonable to think that could be 12. So we have found the correct one due to process of elimination. I like checking it because drawing it out or putting it into a program, you can do that, but just make sure you know what the points are on a box plot. It's the same thing as drawing it out if you can tell me why a box plot is wrong. This one is completely graphically inaccurate. That whisker is way too long. A whisker can only be 1.5 IQRs max above Q3 or below Q1. So that is very visually inaccurate, and we would not put something on the test like that. I find it so interesting that I've completed all but one question, and I still have 1/3 of the assignment left. So this is a big one right here, because if you choose the incorrect box plots, you will get the wrong answers. So which one is more tightly clustered? Definitely region 1. Region 1 is unimodal. Uniform would be just flat. Remember that. People sometimes confuse unimodal and uniform. Unimodal has a mode. Region 2 is going to be bimodal. And we see that right here because we can see the shape in the stem and leaf plot, which is just a histogram with the numbers. That's all stem and leaf plot is. There's the bimodality of it. The distributions are fairly symmetric. And if you were to pretend that you could draw a distribution over this, it might just look like that, and a distribution over this. They're fairly symmetric, and region 2 has outliers. And it's just this one right here. This is not an outlier because you don't see it as a star or as a dot. Now, it's important to note that the bin width on this stem and leaf plot is only 5. That's because we have the low teens, the upper teens, the low 20s, the upper 20s, and you can see it by the numbers that are inside of each bin. So the bin width on this is only 5. And I can't stress enough as I end this assignment here, always, always, always check the key, because there are a lot of tricky questions that it might have been 6.0, 0.60. You never know what exactly we're looking at till we look at the key. So good sort of quiz here to make sure you can figure out box plots and stem and leaf plots. And stem and leaf plots are just histograms with the numbers. That's got it. And good luck.